MS Ramaya University of Applied Sciences.
Hi students, let us discuss standard Proctor compaction test. The aim of the experiment is to determine the optimum moisture content and maximum dry density of a soil sample as per IS 2720 Part 7 1980. Compaction is a process of densification of soil mass by reducing air voids. The degree of compaction of a soil mass is measured in terms of its dry density. The degree of compaction mainly depends upon its moisture content, compaction energy, and type of soil. For a given compaction energy, soil attains the maximum dry density at a particular water content, which is known as optimum moisture content. Compaction helps to increase density, shear strength, bearing capacity. Compaction reduces porosity, permeability, and settlement. The moisture content at which the soils are compacted in the field is controlled by the value of optimum moisture content determined by the laboratory Proctor compaction test. Experimental setup: cylindrical mold of capacity 1000 cc, internal diameter 100 mm and effective height 127.3 mm, or cylindrical mold of capacity 2250 cc, internal diameter 150 mm and effective height 127.3 mm. 50 mm diameter metal rammer of mass 2.6 kg moving in a metallic outer sleeve. Detachable collar of 50 mm effective height. Detachable base plate. Balance of capacity 10 kg and one of 200 grams capacity. Oven. Container. Sieve. Steel straight edge and mixing tools. Experimental procedure. Take around 3 kg of soil passing through 20 mm IS sieve for 1000 cc mold or 6 kg for 2250 cc mold. Add water to it and bring the moisture content to about 4% in coarse-grained soils and 8% in fine-grained soils. Clean, dry and grease lightly the mold and base plate. Weigh the cylindrical mold with the base plate attached W1. Fit the collar and place the mold on a solid base. Compact the wet soil in 3 equal layers by the rammer of mass 2.6 kg and freefall of 31 cm with 25 evenly distributed blows in each layer for 10 cm diameter mold. Or compact the wet soil in 3 equal layers by the rammer of mass 2.6 kg and freefall of 31 cm with 56 evenly distributed blows in each layer for 15 cm diameter mold. Remove the collar and trim off the soil flush with the top of the mold. Collar should be removed by rotating it and breaking the bond between it and the soil before lifting it off the mold. Clean the outside of the mold and the base plate. Weigh the mold with soil and the base plate W2. Remove the compacted specimen from the mold and take respective samples from the top, middle and bottom of the specimen for water content determination. Break the compacted specimen and then mix it with the original sample. Suitable increment of water shall be added successively and mixed into the sample, and the test is repeated for a minimum of 5 to 6 times. Data collection and tabulation. Diameter of the mold, height of the mold, volume of the mold V, weight of the mold with base plate W1 are calculated. Calculations and computations. Wet density of the soil gamma equal to W by V, moisture content in percentage W equal to WW by WS, dry density gamma D equal to gamma by 1 plus W are calculated. The compaction curve obtained is as shown in the figure. The results of optimum moisture content OMC, maximum dry density gamma D are presented.
Dear students, Today we are going to conduct the compaction test. Compaction test can be done in two ways, light compaction and heavy compaction. Today we will be doing light compaction test to determine the optimum moisture content and maximum dry density of the given soil sample. The apparatus required for this experiment are a trowel. The trowel is used to level the soil sample once it is filled in the cylindrical mold. A cylindrical mold. This is the standard cylindrical mold for a light compaction test whose diameter is 100 mm and the height is 127.3 mm. Base plate. This is the base plate over which the cylindrical mold is fixed. Spanner. The spanner is used to fix the cylindrical mold and the collar with the base plate. Collar. This is the collar which is placed over the cylindrical mold while filling the mold with the sample. A measuring jar which is used to measure the amount of water which is added to the soil sample. Mixing tray which is used to mix the soil sample before filling it in the cylindrical mold. And a weighing balance. This is the weighing balance which is used to weigh the soil sample as well as the cylindrical mold and the base plate. Before starting the experiment, we have to fix the cylindrical mold to the base plate and the collar should also be fixed with the cylindrical mold. The inside surface of the cylindrical mold, the collar and the base plate should be greased initially. Now fix the cylindrical mold to the base plate. Fix it tightly using a spanner. Once the cylindrical mold is fixed with the base plate, take the empty weight of the cylinder with the base plate. The empty weight of this comes to around 4.793 kilograms. After weighing it, keep it down and fix the collar on the top of the cylindrical mold. Now measure around 3 kg of the soil sample. So around 3 kg of the soil sample is taken. This soil sample is almost dry. So we will add water according to its dry weight. After weighing the sample, place the sample in the mixing tray. Now this sample is fine grained, so we will initially add around 8% of water into this soil sample. Now 8% of 3 kg will come around 240 milliliter of water. So we have measured around 240 milliliters of water in this measuring jar and we are going to mix it. Slowly add water and mix it thoroughly. Now, after mixing the soil sample properly, divide the soil sample into 3 equal parts. Now fill the mold with one layer of this soil sample, and we have to ram this soil sample for about 25 blows, evenly distributed in the cylindrical mold. For ramming, a rammer of 2.6 kg weight should be used, and the height of fall is around 310 mm. After filling the soil sample in the cylindrical mold for one layer, we are going to compact it using a 2.6 kg rammer falling from a height of 310 millimeter. The compaction can be done using an automatic compactor or manually. For light compaction, we are going to do by manual compaction. This is the automatic compactor which is used to compact the sample, and this is preferred for heavy compaction. For light compaction, in this case, we are going to use the rammer whose weight is 2.6 kg and the height of fall is 310 mm. Place the rammer on the top of the soil layer, raise it to 310 mm and leave it. Ram it for 25 times, and the blows should be evenly distributed. You have to rotate the rammer. As you progress, count the number of blows also. After compacting it with 25 blows, we will fill the next layer of soil sample in the cylindrical mold. After filling the second layer, we have to compact that layer again for 25 blows using the 2.6 kg rammer. Once 25 blows is over, then we will fill with the third part of the soil in the cylindrical mold. After filling the third layer, compact it using the rammer, again 25 blows. After giving 25 blows to the third layer also, now clean the outside surface of the mold as well as the base plate, and then we can remove the collar. Now level the top surface of the soil sample. Remove all the dirt and mud from the sides of the base plate as well as the mold and weigh it with the soil sample. Now the weight of the soil sample is, along with the base plate and the cylindrical mold, comes to 6.588. Since we have taken the weight of the empty base plate and the mold, we can find out the total weight of the soil sample in the mold. After weighing the soil sample, we have to remove the soil sample from the cylindrical mold. For this, we will be using a sample ejector. This is the sample ejector which is used to eject the sample from the cylindrical mold. Now remove the cylindrical mold from the base plate by loosening the screws. Now place the cylindrical mold in the sample ejector. And then raise the ejector. After placing the sample in the sample ejector, switch on the ejector and apply the pressure. Remove the sample to the tray. Break it and take a representative sample from the middle to determine the water content. Break the soil sample and take a small amount of soil from the middle to determine the water content. Now we have to repeat this experiment for various water contents. Completely break the soil sample and add more water to the soil sample. Mix it thoroughly and repeat the procedure for 5 more times. This experiment we have conducted for 8% water content. Now add 10% water content, 12, 14, 16, 18 and repeat the experiments in the same way. Then finally plot the density and water content and get the maximum dry density and optimum moisture content. That finishes the experiment.
At MSR UAS, we spark your imagination unlike any other.